Hello, let's do a lesson here on linked lists. A linked list is a direct competitor to an array. So I feel we should start with comparing a linked list to an array. First thing you should know about a linked list is there's no preset size. You don't declare it to be 5 or 10 or 100 links long. Like a physical chain, if you add more links to it, it gets bigger. If you remove links from it, it gets smaller. A linked list has no preset size, where an array has a fixed size. If I declare an array here of length 5, it's going to be 5. It won't get smaller, it won't get larger. Also, linked lists use small chunks of computer memory. You add items to the linked list and they take up only as much space as a new link would take up. Whereas arrays use large memory chunks. Arrays are allocated as a contiguous block of computer memory. So item 1 will be next to item 2, which will be next to item 3. Arrays are allocated in large chunks. Linked lists are allocated in small pieces. No binary search. You cannot do a binary search on a linked list. You can't go to the middle and start searching from there. Whereas an array, you can start in the middle. You could say go to the middle, and if it's less than this, go to that side. If it's greater than, go to this side. No binary search for a linked list. Yes on binary search for an array. Finally, no random access on a linked list. You can't just go to this item 40 and access it directly. You have to go through the links to get to 40. Whereas arrays have random access. If you want to go to subscript or index 3 directly without going through the previous items, you can go directly to those items. So there's pluses and minuses either way. Right? The linked list, the no preset size is an advantage, but the no binary search is a disadvantage of a linked list. It all comes down to how you're storing data and what your data you're storing. If you know the size of your data, you tend to go with arrays. If you don't know the size of your data, you go with a linked list. Okay, let's start with the class linked list. It's the entry point for the entire list. All access goes through class linked list. If you compare a linked list to a physical chain, it would be the head of the chain. The rest of the chain is connected through it. We're going to trace this code when we build the list, so we're not going to go through it line by line just yet. But the class linked list is basically the head of the linked list, or the head of the chain. The class link is the individual elements of the list. If you come down here and look at it, the element at 10, the element 30, the element 50, each one of these is a link object. Over here, list is a linked list object, but each one of these is a link object. As with the physical chain analogy, as the name implies, these are the individual links of the chain. Finally, here's some code that creates and builds the linked list. It's important to see how individual links get connected to the chain, and that's what this code is designed to do. The first line will create the list, and then we'll insert elements into it and finally delete an element from the list. It's important to see how the individual links get connected to the chain. Let's trace this code line by line and see what happens. On this first line up here, we're going to declare a variable called the list and build a linked list object. This will also call the constructor method and initialize that object. So we're going to declare the list variable. That's the declaration of the list variable. We're going to build the linked list object. There's the linked list object there. And we're going to run the constructor right here in order to initialize that object. And you see we do a first equals null. The value null indicates there is no first object in the list. Null literally means no object has been assigned to this reference variable. So the null in the first variable tells you we're dealing with an empty linked list, as you would expect it to be when it's first created. There are no items in our linked list at this point in time. Which brings us to the next line of code. We're going to go to the list object. The period says go inside and run a method. The method that we're going to run here is the insert first method, and that's what that arrow is telling you. We're going to pass it 11 as the parameter, and 11 will be assigned to the ID variable. During the execution of this code, we're going to create a new link object. We're going to create a new link object. This will call the link constructor and execute this code. Look at this link object that we created. There's the variable new link. We've allocated a reference variable called new link, and it will be attached to this object here. You can see over in the link class, when you build a link object, there's a data variable and there is a next variable. You can see the data next variable is part of our link object. Now I also drew this in blue just to make it a different color to separate it from the link list object. Anything in blue is going to be a link object. This one over here in black is a link list object. They are two different objects. So let's execute the code in the link constructor, and we'll initialize the data 11. We'll assign the 11 from the parameter ID to the data variable. Remember, we set 11 as the parameter over here. It passed the 11 over to link, and the 11 showed up here in our object. Now we're going to go and do a new link.next equals first. We're going to move the null from the first to the next variable. See that null right there in the first variable? We are taking that null from the first variable and moving it over to new link.next. Well, where's new link.next? It's over here. There's new link. There's new link.next. There's the null variable. So it moved from the first variable over to new link.next, and it showed up there. Now, one thing I want to be clear here, we're using what's called default mode. If you notice up here in the link class, we did not declare next to be private or public. What does that mean when you don't declare it to be private or public? It means all the classes in the same package have access to the next variable. So it's not shown here, but class link is in a package and class link list are in the same package. When two classes are in the same package, you have direct access to default variables. Linked list has access to the next variable because it's declared to be default permission. Now we're going to say first equals new link. First equals new link. We're going to assign the first variable over to the new link variable. I want first to point to the same object as new link points to. Now, both of these blue lines are references to link objects, and all I'm doing is moving the reference from new link over to the reference first. So first reference the exact same object as new link, as the name implies. Look at the name of the method we called, insert first. We want to make this object that we're inserting the first object in the link list. Now, we'll return to the original code. We hit the end of this insert first. We came back. We'd finished this call to insert first. So the code drops down and executes the next line. Go to the list object. The dot says go inside of it and run the insert method and pass it 22 as a parameter. So 22 will come in as ID the next time we run this method. So this is a call to the method to insert a link object into the list with ID equal to 22, and this will become the new quote-unquote first object. Tracing the code inside of insert first, we're going to call the link constructor to initialize the link. We'll pass the ID 22 as the parameter to the link, and we'll create a brand new link object. Notice that new link is a local variable. As a local variable, new link gets created every time this method is called, and new link disappears when this method is done. So I created a new link variable and I assigned it a link object, and I call the link constructor to initialize its variables. And the link constructor takes that 22 that was passed to insert first, that 22 right there was passed here, then passed over here, and now ended up here inside the new link object. We assign to the data variable the value 22. Returning back here to execute the next line of code, we say new link.next equals first. New link.next equals first. Well, here's the first variable. It's this blue line that points to this old first object, the object with an 11 in it. So see that reference to object with 11 in it? We want that reference to be assigned to new link.next. Well, here's new link. Here's new link.next. We want to reference the same object. Remember, one object can have two references, and at this point in time, newLink.next and the first reference are pointing to the same object. What this line of code created here, was this blue line, a reference from the next variable to the object containing 11. First equals new link. What is that? Well, kind of doing the same thing as the line before. New link is a reference to this object. I want first to point to the same object. Make new link the first object in the linked list. It's this blue reference line right there that is created by this line of code. Remember, a reference refers to or points to an object, and this is the object I want first to point to. Recall the original name of the method was insert first. Insert a new first object into the linked list, and sure enough, 22 is now the first object in the linked list. Returning back to the original code, right? When this code exits, two things are going to happen. First, the new link variable is going to disappear because it's a local variable and it gets removed when you return from the method. Second, we'll jump back here and execute the line of code after the previous call to insert first. And that is a call to insert first with a 44 as a parameter. So the 44 will be passed to ID here, and we will be requested to create a new first object for the linked list. Notice where this new object is going to go. It's going to go as the first or at the beginning of the list. We create another new link variable. Remember, this is a local variable. A brand new link is created every time this line of code executes. We're going to call the link constructor to build the object. There's the link object being created. Remember, all the link objects are in blue on this slide. And we're going to run the link constructor to initialize the data in there. And the 44 that was originally passed to ID here and then sent on to the constructor to ID there is assigned to that new link object. Insert the first object 44 into the linked list, and you can kind of see that it's going to go at the beginning of the linked list. I'll say newLink.next equals first. That's this blue line right there that was created by this line of code. First is a reference to the object containing 22. I want newLink.next to reference that same object. Can you see the chain developing? I'll then say first equals new link. What does that line of code do? Well, new link is this reference right here. See that blue line? New link is right there. I want first to equal the same thing. So first will point to the same object that new link points to. This object with data equals 44 is now the first object in the linked list. We hit the end of this routine. That means the new link variable went away because local variables are deleted on demand. But don't worry, new link went away. We still have this first reference pointing to that object. No one's going to touch it. We'll come back here and we'll create a link named gone and set it equal to the list.delete first. Instead of adding to the linked list, I now want to remove from the linked list. So I've allocated the variable gone, but I haven't set it equal to anything because this hasn't returned yet. And I'll jump over to the list object and run its delete first method. The list dot says go to the list variable. The dot says go inside and run a method. The method that I'm going to run is delete first. So let's execute delete first and see what happens. First, we're going to create a temporary variable and set it equal to first. So see, first is attached to this object. Temp should be pointing to the same object. We're going to hold on to it just for a short time so it doesn't get deleted by garbage collection. First equals temp.next. What are we doing there? Well, temp is pointing to the first object in the linked list. So its next variable is pointing right there. See that blue line? That is temp.next. If I set first equal to temp.next, you can see that first is pointing to the same object that temp.next is pointing to. Basically what I'm doing is I'm bypassing the old first object and making 22 the new first object in the linked list. It was this line of code that essentially took data 44 out of the linked list. Now the reason I have the temp variable on there is so I can now return a reference to the temp variable. What I want to do is when delete.first returns, I want to set temp equal to gone. So I need this reference so garbage collection doesn't delete the object. I want to send 10 back and assign it to gone. And you'll see, notice where the line temp points to. It points to this object that was deleted from the linked list. When I execute the next line of code and I say gone equals, I'm setting gone equal to temp. And I transferred the temp reference to the gone variable. The only reason link object 44 is not removed from memory is the gone reference. I'm holding on to it just for a short bit of time here so garbage collection doesn't delete it. Right now at this point, essentially the link object with data 44 is out of the linked list, but it's not completely deleted because the gone reference is attached to it. If we don't need this object or we're done using this object, at this point we can allow garbage collection to delete it by setting gone equal to null. I just added this line of code to show you what happens when an object loses its last reference. Without the gone reference, garbage collection will go ahead and delete the memory that object was occupying. And you can see that the list.delete first successfully removed the 44 from the linked list. All right, that is sort of an introduction to a very simple linked list. Let's move on and look at one of the things we'll do with a linked list. Linked list traversal. What we're going to do is loop through all the data stored in a linked list. Recall a previous example. Here's our list and it links 10 and 20 and 30 and 40 and 50. A traversal of this linked list would visit 10, 20, 30, 40, 50 and stop when it hit the null here at the end. That's it. We're just going to loop through the entire linked list and see or print all the items in the linked list. What we're going to do here is write a loop that starts at the beginning of the linked list and jumps from link to link until it reaches the end of the linked list. Here's our while loop that's going to do the work for us. It's just going to start at the beginning or the first object and jump from link to link until it reaches the end. First up, we're going to create a variable. Link current equals the list.getFirst. You got to follow these variables and you got to follow these dots. The list says go to the list variable, the list reference variable. The dot says go inside of it and run the get first method. Well, this is going to be a very simple get first method. It's just going to return the first variable. So when it returns the first variable, it's returning this blue line, this reference from first to a link object. So it returns that variable, that reference, and assigns it to the current variable. So we created and declared the current variable, created it, and notice how the reference gets set to the same thing that first is set to. See this? First should be assigned to current. Current is referencing the same object that first is referencing. Basically, we transferred the value in the first variable over to the current variable. And current is now pointing to the first object in the list. While current is not equal to null, well, current is a legitimate reference. It's pointing to a real object. So not equal to null is definitely a true statement. As a true statement, we need to go inside the loop and execute the loop. We'll do a system.out print line. We're going to follow that blue reference line from current to get data right here. Get data in that object will return the 44 within that same object, and it'll print it to the output, and a 44 shows up here on our output. Now I drew a line from this object to where the 44 showed up in order to show you that get data would be sending back that 44, and it's that 44 that shows up on the screen. Next up is a crucial line. It's so important, I'm going to split this up into two steps. First thing I'm going to do is I'm going to access current.getNext. Look at current.getNext. It is the reference from 44 to 22. If you look at current.next, it's this blue line here. That's why I drew the red arrow here. Current.next is this variable right there that is referencing or pointing to that object right there. I'm going to basically return or assign this blue line to current. And notice how current moved to the next object in the linked list. We're going to assign the reference that points to the link object with 22 to the current variable. We just jumped to the next item in the linked list. See that? Current.next was this value. We assign that to current, so current is pointing to the same place that that reference is pointing to. We'll hit the end of the loop, and we all know what it does at the end of the loop. Whoop! It goes back up and does it again. At this point, we're going to check while current is not equal to null. If you look at current, is clearly pointing to an object. Current is clearly referencing an object. So current not equal to null is very much a true statement. As a true statement, we're going to go inside the loop and execute the loop again. Follow the blue reference from current. Follow this line right here. Current.getData is going to return this 22. GetData is a simple get method in this object that will send back the value of the data variable. It will send back the 22. The 22 will be supplied here, and you'll see I drew a line from this object. The 22 that getData return is sent back, and there it shows up on the output. List contains 22 now shows up. Do you see where it got that 22? It did current. Dot says go inside of current. Get data in this object sent back a 22. When it sent back a 22, the 22 showed up here on the output. And this line is so important, I broke it up into two pieces. You need to understand what's happening on this line. Look at current.getNext. Current.getNext, follow current. Current goes to here. .getNext goes to here, and will return the value of this reference, the next reference in current's object. Well, it's that blue line right there. That's why I drew the arrow there, because what we're doing is we're returning a reference to that object, the object that contains 11. And we're going to assign that reference to current. That current equal says I want current to point to the same thing that current.next was pointing to. Well, there was a previous current.next right there. I want current to point to that object right there, and we just jumped the link. Current is now pointing to the object that has data equal to 11. We'll hit the end of the loop, whoop, and we'll go back up and do it again. When we get back up, current not equal to null. Current not equal to null is a true statement. Current is clearly pointing to an object. If current is pointing to an object, not equal to null is true. As a true statement, we're going to go inside the while loop and execute the code inside the while loop. We'll do a system.out print line. Will show up on the screen, and we'll pass it current.getData. Follow the blue reference. Here's current. Follow the blue reference to .getData. Current.getData will run this getData. This getData will return an 11. When it returns 11 to the caller, that 11 will go back and show up on the output. And you can see where this arrow, the arrow is pointing to where that 11 is. Right? That 11 came from this object. And specifically, it came from current.getData, which accessed the data variable 11 and sent it back to the user. And 11 shows up there on the output. We're still going to go through this loop one more time. We're not done. Even though we're technically at the end of the linked list, we got to go through this loop one more time and pay close attention to what's happening here. Current.getNext. If you look closely at current.getNext, follow the blue line, getNext will access the next variable in here. Well, the next variable contains a null. That's kind of the marker for the end of our linked list. Current.getNext is going to return a null. And where's that going to go? It's going to go and be assigned to the current variable. See that null in the next variable? It is being sent back to current and assigned to the current variable. So current currently contains null. Assign null from the link object with 11 in it to the current variable. And that's what that line of code does. We'll loop back up because that's what we do when we hit the end of the loop. But something different's going to happen this time when we loop back up. This time, when we ask, is current not equal to null, we're going to get a different answer. Current not equal to null, well, you can clearly see a null there. Current is equal to null. So not equal to null is clearly a false statement. And when this statement goes false, we're going to exit the loop. Look at that line. It's time to leave the loop. When we hit the null at the end of the linked list, the loop is over. And we're done traversing the linked list. That's it. It's a very simple loop. Start with the first object in the linked list and loop until you reach the null at the end.